Welcome back, students. So in the previous class we have done some array program, okay, of data structure. So one last program was left. You see, write down what will be the address of fifth element. What will be the address of fifth element in a floating point array? In a floating point array implemented in C++. Okay. The array is specified as amount 16. The base address of the array is 1058. You see, what will be asked? We have to find the address of fifth element in a floating point array. Okay, means there is an array. The array name is what? Amount 16. Okay, amount 16 means suppose this is an array. This array is starting from what? 0, 1, 2, going to last one is what? 15. Sorry, amount 16. One second, not 16, its index is 15. Because this 16 value, this is means 15, 0 to 15, okay? We have to find 1, 2, 3, 4, 5. Okay? Their part will be etc. What will be the address of fifth element in a floating point array implemented in C++? Fifth element 1, 2, 3, 4, 5. Suppose there is something element. Okay, some floating point elements. Anything floating point means anything decimal number, suppose 61.2 or suppose anything like that. So we have to find the address of this. Okay. The array specified amount 16. The base address of the array is 1058. What is the definition? Means what is the formula? You see, the index is what? Fifth element means index is 4. Means your I is 4. Okay, your I is 4. Means you have to write down address of amount 4 is equal amount 4 is equal, what is the formula? ES plus base address, one second. Okay, what is the base address? 1058 plus ES means what? Size, element size. And what is the floating point element size? You know, in floating point data type, what is the memory size? 4 bytes. Means this is 4. Subscript is 4 because this fifth element means subscript is 4. And lower bound is what? 0. Means 1058 plus 4 for the 16 means 1074. Your answer is 1074. Okay. Again I tell you, see, What will be the address of fifth element in a floating point array? This is a suppose floating point array, and this array name is what? Amount. Diagram is not given in the book. I show you this concept. From starting 0 to it go to 15 because there is 16 memory block, right? Fifth element means what? 1, 2, 3, 4, 5 means subscript 4. Okay, and base address is given by 1058, right? And ES means element size, and element size is what? In floating point data type, element size is always 4 bytes. This is, that's why this is 4. I means is this subscript 4, and 0 is lower bound. Lower bound means this lower index 0. After calculating it, it is just simple maths 1074, right? Okay. Next is very important topic of data structure. Mostly every year questions coming from that topic, and that topic will be searching, okay? And there is two searching topic. There is two searching technique. One is linear search and other one is binary search. Means every year you can say every year in final exam minimum one questions coming, minimum one questions coming from that topic, searching. Means either linear search or binary search. If you check the previous question paper, then you can find minimum one questions from that topic. That topic is very important of data structure, okay? Algorithm is very important. Now we have to study algorithm, okay? Program we have done many program. Program is also important, but mostly in data structure, algorithm is important. Algorithm is coming in exam, right? If you see the question paper, then you find it. So, the topic is searching, right? I don't give you the definition notes. This is already available in the book. You can see it. Searching, in searching, there is two techniques for searching, right? One is linear search and another one is binary search, right? So what is linear search and what is binary search, and why searching is important? That is also one concept. Why searching is important? Searching is important for you have to search a required item from an array. Okay, this is the operation. Means searching is operation of array. Okay, this is operation of one dimensional array. Okay. This is operation of one dimensional array. So, why searching is needed? Because you see, searching is means what? You have to search a special value from a large number of arrays. Suppose there is an array which has more memory blocks, suppose 20, 25, but you have to find a item from that array or middle of the array or anything from the array, from the position. Then you have to find the array, required item from that array by using that searching technique, right? In linear search, we have to be compare the value I show you. Suppose this is an array, okay? You see it. 0, 1, 2, 3, 4, 5, 6, 7. Okay. Suppose there is a 7 means 8 element. Suppose this is an integer array. Integer A double R 8. 11, 12, 13, 14, 15, 16, 17, 18. Right. Means suppose we have to find this searching this item 14. Then how it will be operate in linear search? In linear search, we have to be find this 14 with compare with all other value. We have to be 14 with this, like that. This is a simple concept. Okay, I teach you. But in binary search, some special formula will be applied, right? Okay. We shall start the linear search. Then you easily understood the whole mechanism. First is linear search, okay? First one is linear search. Okay, you see, I write down. In linear search, each element of the array is compared with the given item to be searched for. Given item to be searched for one by one. One by one we have to be searched the given item with the remaining element of the array. I show you how it will operate. You just easily understood. Okay, this is the basic definition. Okay, now we have to be find the algorithm. Okay, what is algorithm? This is the important concept. Algorithm for linear search. Okay, what is algorithm and what is the difference between algorithm and program? Okay, algorithm means what? The main logic. Okay, in program, suppose when we done a program in C++, means program means what? We have to be, it is like maths. Program means it is fully mathematics. Okay, but using some syntax, using some coding, header file, function, etc., etc. But in algorithm, this is the main root of logic, means main concept, means many possibility. Algorithm is very small as compared to program. Program is many, very large, many lines, 100, many lines. We have done many large program up to till now. Okay. But in algorithm, the structure is small, but the main behind the logic is very fast. Okay, means suppose when we define an algorithm, means we define the main logic, and with this logic, with the use of this logic, we can done many program, 1, 2, 3, 4, many program. Okay, like mathematics. In mathematics, what one program can done by many ways. Like also is in addition program. Suppose our C++ addition program, A plus B addition program. Okay, this addition program is done by many ways. Directly, you can done by directly. I already teach you faster directly. Or you can done A plus B by using class, A plus B using function, A plus B using constructor, pointer, everything. Many concept is for one program. But if you find an algorithm for this addition program, means algorithm is always one. Means the main logic is one. Program is done by various way, or compiler is used in many compilers. We done because our syllabus in Turbo C, because we in Windows operating system. That's why we done in operating system Windows. Okay, or if you done the same program in Linux or other compiler, code blocks or some other compiler, then the syntax style is different. Okay, like we done hashtag include conio rotates. If you done the same program in Linux, that you can not need to be mentioned the hashtag include conio rotates. Okay, you have to be write that using namespace std, or we can we write some function for get ch, okay, clr str. But when we done the same program in Linux, then that type of function is not working. You understood what I want to say? Means the syntax is different for every different compiler. Okay, means program is done in different ways. In different compiler, syntax is different in different operating system, different compiler. But algorithm is the main logic. Algorithm is a root. Okay. Every program has a unique algorithm. Algorithm has the main root. You can say like that. Okay. I hope you understood. Means just you simply understood that algorithm is the main logic, main concept. Okay, main concept. Okay, I write down algorithm for linear search. Mainly algorithm is coming in data structure. Okay, mainly algorithm is coming in data structure. But in exam, every year questions coming. Write an algorithm for that, write an algorithm for suppose for searching, sorting. Also program is also coming, but algorithm is coming for this data structure part. Okay. See. For algorithm, you have to be write like that. Initialize counter by assigning lower bound value of the array. Lower bound. Right? Initialize counter by assigning lower bound value of the array. Lower bound means what? The smallest index. Okay, upper bound means maximum, highest index. Right? Step 1, we have to write like that. Step 1. What step? Set ctr is equal L. I teach you. Just first of all write down. Set ctr is equal L. What is this? We just write that in C++. L lower bound is 0. Right? Step 2. Okay. Repeat steps 3 through 4. I teach you line by line, just you write down first of all. Until ctr greater than upper bound. U means upper bound. Okay. In C++, U upper bound is size minus 1. I hope you understand why it is size minus 1. I tell you. Step 3. Now important. If ARCTR is equal item double is equal, then print search successful. Print ctr. Ctr means counter. Okay. Is the location of item. Location of item. Break. Okay. Now step 4. CTR is equal to CTR plus 1. Step 5. If CTR greater than U, then print unsuccessful, right? And last step is step 6, E and D, end. Means this is the end. Full stop. You see? Now, don't be confused, okay? Don't be, hesitate. You just simply understood. Algorithm is logic. First line is for definition. Initialize counter by assigning lower bound value of the array. Okay? We initialize this CTR, control. Don't be underline, okay? I just underline for your understood purpose. This CTR is what? Counter. We assigning this lower bound, suppose this is the array, okay? Suppose this is the array. Starting from 0, 1, 2, 3, 4, 5, 6, 7. This 0 is lower bound and this 7 is upper bound, right? And this lower bound is assigning in CTR. CTR means one counter. We assign a counter where lower bound value of the array is what? Stored, right? That's why we write in C++ lower bound is 0. Okay? You see, repeat steps 3 through 4 until CTR greater than U. Means what? Up to CTR is what? This is CTR. CTR means this is the index. And he said in linear search what? We find the item, means we find the search value, what value we should be searched. By searching by what? It will be compared with the element of the array one by one. You see the definition? Means you go through the like that in increment purpose. First suppose this is the array, okay? 11, 12, 13, 14, 15, 16, 17, 18. Suppose your required value is this, searching item is this, 17. Suppose many possible condition, okay? Just this is the first possible condition. Suppose you search this 17, then you first of all go to the this, CTR your 0. Compare 17 with 11. This will be not same, okay? Then you go through this 1. Compare 17 and 12. This is also not same. Then you go through this. This is not same, like that. We will go to further like that. That means steps 3 through 4 means steps 3 through 4. This will be loop concept. This will be running until CTR greater than U. Until. Suppose your search item is not 17, suppose 19. You go through this, you go through this, go through this, go through this. Your item is not searching. Means your item is not here in the array. Means what? Search unsuccessful. Right. See, means you have to be find until CTR greater than U. Means CTR greater than U means until. When CTR greater than U means it is not possible. Means above, suppose you have to search index 18 here. It is possible? Not. Why was it not possible? Because your upper bound is what? Up to 7. You can't be find the index 8 here. Your upper bound is what? 7. Means until this means up to this possible. When this condition coming means it is impossible. Right? Why I want to say you? And they say in C++ upper bound is size minus 1. Why size minus 1? In here you see what is the size of the array? 8, 1, 2, 3, 4, 5, 6, 7, 8. And upper bound is what? 7. Means one value decrement. Why? Because we starting from the 0. That's why your upper bound is what? Size minus 1. Right? If AR CTR is equal to item. AR CTR means array. Suppose your value will be 17. Means in this, when you coming like this and you see this in the index 6 means 17 is equal to 17 means search successful. Print CTR means what? Print this index 6 is the location of item, means your location of item is what? 6. Break. Otherwise you go through this CTR is CTR plus 1 means you have to be searching for increment 0, 1, 2, 3, 4 like that. If CTR greater than you, then print unsuccessful. I already told you. You got the logic. And why we use double is equal? You know the difference? This is equal and this is equal. This is for assign operator, okay, and this is for equal. Means this is the main operator for equal purpose, and this is the assign operator. These are some difference, okay. Sometimes also questions coming in your final exam, and for 1 mark, basically, one is the difference of one equal and double equal, okay. You see, again I am show you. CTR means you have to assign a counter, okay, for the index. And initially in CTR, what index will be stored? The lower bound means minimum index, right? And minimum index is always 0, and upper bound is always what? Size minus 1, right? And you see, this is for the loop concept, okay, loop concept. Repeat steps 3 to 4 until CTR greater than you, means up to this. When it is greater than you, greater than 7, means upper bound, then it is impossible, okay. And if AR CTR means what? This is the array, AR means array CTR. At the respective, suppose you have to search for item 15, you go through this, compare, go through this, go through this, go through this. In this, your AR CTR means AR4 is equal to 5, is equal to 15, okay. Means your required item is 15, okay. And AR CTR means 4, and AR means this is the array. Suppose we take a array AR name, user defined. Search successful, and print CTR means this. 4th is the your position, is the location of item, and this is increment. If CTR greater than you, means greater than you. Suppose you find the element of suppose 20. 20 is not there. Array 11, 12. You just check it. Suppose this is 20. Suppose you have to find an element of 20. You check it for every value. There is no counting up to CTR greater than you. You check it for 0, 1, 2, 3, 4, 5, 6, 7, and 20 is not here in array. Means 20 is not here. 20 is compared to 11. This is not equal 12, not equal 13, 14 is equal up to CTR U. When greater than U, this is not equal. 20 is equal, not equal to any element in that array. Means your print is what? Unsuccessful. And last one is end. Okay, this is the main logic. Algorithm is the main logic of the program. Okay. Okay, in the next class we have done the respective program for that linear search, okay, and that is also very, I write down here, this is very important, okay. This linear search and binary search algorithm and program is very important, also for practical, okay. You just simply read it, and if you have any doubt regarding this, you can ask me, okay. Thank you.